Hello. This is a section that describes how TCP establishes a session that is requested by Hypertext Transfer Protocol. HTTP requests the TCP to set up this logical connection in order to transfer messages and data from the client to the server. To give you perspective, the next two slides are showing these two protocols inside the client and the server. Notice inside the client we have HTTP. It sends a message to TCP that says set up an end-to-end or client-to-server connection across the wide area network. Remember earlier we described the wide area network to you, but TCP is the one we're going to talk about in this session. So notice here is the TCP IP architecture, which is HTTP over TCP over IP over Ethernet. Whenever HTTP puts a message inside that TCP header, the process is called encapsulation. In the server we have that TCP IP architecture that is going to respond to the TCP message. The application here is the browser protocol HTTP, but TCP is the end connection at the server for the client requesting support for HTTP. Inside the client, here is the TCP header. Just this header is sent as the initiation of the session. Basically, the destination port inside the client, or the destination port inside the server, is port number 80. That is the number that identifies HTTP or the application HTTP. Inside the client, the source port is 5000 because it has to have a number different than 5000, so it records the source port and the destination IP address of the server and the source port 80 inside the client in what is known as a message control block. We'll talk about that a little bit more in a minute. But also all the other information that's sent. We have sequence numbers to keep track of the messages that are sent, acknowledgement numbers to record the acknowledgments of data that's sent. Notice that Windows field. That Windows field tells the destination, server, and client how large the amounts of data that are being sent. And also notice that TCP has an error detection 2 bytes for a checksum. And notice there's a 2-byte urgent pointer that can set priority for data that's sent between the client and the server. When the client sends the server a setup message, it basically tells it how much data it's going to send, and it sets up a message control block that allows it to record information about the session at the server. Remember, it's the destination server is going to be a socket. A socket is an IP address and the destination port number of the application in the server. Once the data is received in the server, he sets up another message control block in his memory that records this session. He acknowledges the session to the client by sending back its own TCP header, and it records the information about the session in its own message control block. Once the client receives the final acknowledgement, it sends an acknowledgement of the setup. This entire process is what sets up a virtual circuit from the client to the server. We'll talk about virtual circuit in just a second. Here's the data inside the server. Notice now when data is going back from the server to the client, the destination port in the client is 5000 and the source port is 80. Still got the sequence number, still got acknowledgments, still got the window field of 1000 bytes and all the other information we talked about, but this is the header that goes back to the client as of an acknowledgement of the session being established between the server and the client. Notice the data here is HTTP. This slide gives you a picture of the logical virtual circuit between the client and the server. Both are at port 80 because they're communicating for HTTP and application. And data can be transferred between the client and the server or the server to the client across this software or virtual circuit. After the session has been established, what you need to do, whether you're at home or any other time, you go out on the internet. If you go to the command line, go to run and type command CMD and hit enter, and then type this command netstat, you should see this type of a picture that records the local address, the foreign address, and also records whether the TCP session has been set up or not. Notice established means set up. But also notice that if it just sends a synchronization message, SYN, it records that it sent it, but there is no response to that. If there is no response to that, you see the time wait. But the key is here is there is a TCP session setup. So for troubleshooting purposes, if things aren't working properly, everything from the client to the server, from TCP to TCP and the client to the server, everything's working. So you don't need to ping, you don't need to trace route, do anything else. So this would be the first place you would look for troubleshooting a TCP connection or any type of an internet connection. After that virtual circuit has been established, now the server can download its web page to the client. This picture shows you that it broke the web page into 4 pieces called segments of 250 bytes each, and it downloads 250, 500, 750. And the key is when 750 doesn't make it, it acknowledges 500. And then what happens is, what'll happen we'll show you on the next slide. But the key to this is this is meant to show you that it downloads pieces of messages from the client to the server. The client puts them in memory and acknowledges the highest byte number received that is continuous or contiguous. Remember, this is an end-to-end connection. Notice the picture. Last but not least, when the client acknowledges 500 and the server has transmitted 750, it will retransmit everything not acknowledged. And in this case, he's transmitting 750, or retransmission. The process of retransmitting 750 is called error correction. That is a part of data transfer that TCP provides. Some people call it retransmission. The key is it is error correction. The process of acknowledging the data, all right, is what supplements that.